Now, 4.4 are all word problems, and they all have the same goal. They're trying to find a max of something or a min of something. And the process for solving these is consistent throughout. The first thing you're going to want to do is identify all the given information as well as what you don't know. Oftentimes that involves drawing a picture. That's the best way to start figuring out what you know and what you don't know. Then your second task, perhaps the hardest task, the task that we spent our last video on, is writing an equation relating the key components to each other. The third step, which we have gotten pretty good at because it's what we did back in 4.2, is to find the maximum or the minimum value. And so if you recall, this involves finding where the derivative is equal to 0 or is undefined. And then you plug in those critical points or your endpoints to figure out which one would yield the highest or lowest value. If there's only one critical point and no endpoints, then you can use a sign chart to tell if it's a max or a min. So these were the steps that we did in 4.2. And so that's what you would do with your own equation that you write to find the maximum or the minimum value. Now, because these are word problems, there's a fourth component, and that is you need to interpret your solution. And make sure you answer the question that's being asked. All right, so let's go ahead and try these out. The beginning of the problem will sound very familiar because it's what we spent a whole day working on just last class. So a rectangle has its base on the x-axis, its upper two vertices on the parabola y equals 12 minus x squared. And then here comes the max question. What is the largest area? So we want to find the maximum value of area. So let's go ahead and start by drawing a picture. That's a good way to figure out what I know and what I don't know. So I know that this rectangle is going to have its upper two vertices on this parabola 12 minus x squared. So 12 minus x squared would begin at 12, and then it would be a parabola facing down because it's a negative x squared. And my rectangle has its base on the x-axis and its upper two vertices on this parabola. Very typical type of problem. So I need to somehow figure out an equation that would relate area to the dimensions of this rectangle. And I need to relate that to my given information. So I need a way to somehow figure out what the dimensions of this rectangle are in terms of x. Well, I know that this point right here would be x, would have an x value for the x coordinate, obviously, and it would be this length of x from the origin over to how far that point went to the right. Now, how far you go up depends on this parabola, because the point has to intersect the parabola. And it just so happens that the y value of this parabola is equal to 12 minus x squared. That is how you find the points on this parabola, is you take that x value, you plug it into this equation, and that gives you the y value on the parabola. So this y value would, right here, would be 12 minus whatever this x value is squared. So that is the ordered pair for this point. So that means you go over x and you go up a distance of 12 minus x squared. That's the height of the rectangle. So then the area of the rectangle in terms of x would be the base of the rectangle times the height. But I want to get it in terms of x, So if you again look at this rectangle, to get the entire base, I need 2 x's, because x was only the distance from the origin over to this point here. So to get the whole base of the rectangle, I need 2 of those x's. And then the height, how far up you go, we talked about, depends on that parabola. So we use the equation of the parabola to determine the height. So there is the area of the rectangle in terms of x. This time I'm going to simplify it a little bit. All right, now we need to find the largest area. That means I need to find a maximum value of a. To find the maximum value of a, I'm going to find where the derivative equals 0. And the derivative of this area is 24 minus 6x squared. So I'm going to set that equal to 0 and solve for x. So I'm going to get 6x squared equals 24, x squared equals 4. So x is going to be either positive or negative 2. All right? Well, that just means it could either go this way or it could go that way. So we'll just use the positive value because we want positive area anyways. So we'll take off the negative 2. So I know that this area right here, is going to reach a max or a min when x is equal to 2. So what I'll do is I'll go ahead and plug this into the original to see what the area would be. And so this area ends up being 32 feet squared. And so that is either my max or my min. I'm pretty sure it's my max, so to make sure it's my max, I'll just test something. I'll just test a point to the left and right of 2. So we'll just quickly test 1 and 3, just to see if the function was going up then down or if it was going down then up. And I'll test these with the derivative. So it's kind of like a miniature sign chart without the chart. So if I do a prime of 1, I would get 24 minus 6. That's positive. If I did a prime of 3, I would get 24 minus 6 times 9. So I'd have 24 minus 54. That's negative. So that tells me that to the left of 2, the function was increasing. To the right of 2, the function was decreasing. So that means it hit a max. So there we go. There's the largest area that this rectangle can have. So let me answer the question now. So the largest area was equal to 32 feet squared. And then it also asked for its dimensions. That would be the base and the height. So the base is just 2 of the x's. So 2 of those 2's, so that would be 4. And then the height is 12 minus whatever x is squared, and x was 2. So it would be 12 minus 4. So this rectangle would be 4 by 8. And so those are the dimensions. And just one other thing I wanted to point out about this example is x is allowed to change. It's not a constant, it's a variable. So this area is going to be changing with respect to x. So for example, if I picked a different x value, like maybe right here, and that was my x value, that would change my rectangle because to get up to the top of the parabola, I'd have to go up a lot higher. So you could have a rectangle that looks like that, and your rectangle will change size and shape and area depending on the value of x. And so that was the meaning of this function here, was the area of whatever rectangle you get depending on whatever x value you choose. Okay, so let's move on to the next example. So it's a classic rectangular patch question. So we have a 216 meters squared rectangular pea patch. It's to be enclosed by a fence and then divided into 2 equal parts by a fence parallel to one of the sides. What dimensions for the outer rectangle will require the smallest total length of fence? And then, of course, how much fence will be needed? So we begin, of course, by drawing a picture. I know that the area of this rectangular pea patch is 216 meters squared. I also know that it's going to be divided into 2 equal parts. I could either go this way or that way. It doesn't really matter. I'll just go that way. And yeah, because the fence has to be parallel to one of the sides. So it could either be that side or this side. What dimensions for the outer rectangle? So we want to find this and that. The total length and the total width of the outer rectangle will require the smallest total length of fence. So that means we want to find the minimum of perimeter. Because the total length of fence, that is the length around. But don't forget that we also used a fence here to divide it in half. So it's actually going to be 2 of the longer sides and then 3 of the smaller sides. So perimeter, and let's go ahead and we can call this one X, and we'll call that one Y. So perimeter would be 3 of the smaller, shorter sides, and then 2 of the longer sides. But the problem is I need to get perimeter in terms of just one variable. I can't take a derivative with respect to X here because I have an X and a Y. I need to somehow get it all in terms of X. That's where this 216 meters squared comes into play. Because I know that the area of this rectangle, which by the way happens to be X times Y, and I know that the area equals 216. So what I can do is just divide both sides by X, and I can find out that Y is simply 216 divided by X. And I can use that expression for Y over here in the perimeter formula. So now I want to get the perimeter in terms of X. So substituting 216 over X for Y gives me 3X plus 2 times 216 over X. And that gives me, that becomes 3X plus 432 over X. So this here is my equation for perimeter. And what I'm trying to do is find the smallest, the minimum amount of perimeter. So I need to find when the derivative of this is equal to 0. So the derivative of 3x is 3. The derivative of 432 over x would be negative 432 over x squared. Because you can think of 432 over x as 432 times x to the negative 1. And then you would use a power rule. Negative 1 times 432 is negative 432 times x to the negative 2. So you would drop that down and make it x squared. Now, I need to find when this derivative is equal to 0, because that will be when this will hit a max or a min. So to solve for x squared, I could start by subtracting 3 to both sides, and then do some simple cross multiplying. So I would get negative 3x squared is equal to negative 432. Then I could divide both sides by 3, by negative 3, and get x squared is equal to positive 144. So then that leaves me with either positive or negative 12 for x. So clearly I'm not going to use negative 12 because I'm talking about the length of this fence. So I'm not going to use a negative length. Now, I need to see if that would be my max or my min. So I could test something to the left and the right of 12, like 11 and 13, and I'll test that with my derivative. So I'll do that maybe over here. So I'm going to figure out what the sign of p prime 11 would be. And so that would be 3 plus negative 432 divided by 121. And so 432 divided by 121 would be a little bit more than 3. And it would be negative. So then p prime of 11 would be negative. And then if I check p prime of 13 and do 13 squared, I end up with 432 divided by 169. And if you do 432 divided by 169, you'd get something a little bit less than 3. So you'd have 3 plus a negative number that's smaller than 3. That would be positive. So what that tells me is that this function here was decreasing to the left of 12. So it's decreasing to the left of 12 and then increasing to the right of 12, making 12 the minimum value that we seek. So the question was, what dimensions for the outer rectangle will require the smallest length of fence? So let's answer the dimensions first. So x we found to be 12. That's this guy here. So then we just need to figure out what y is. And as you recall, y was just 216 divided by x. So the dimensions are 12 by 216 divided by 12, which is 18. So that answers the dimensions question. And then it also asks for what is the amount of fence? Well, the amount of fence was right here, 3 of the x's plus 2 of the y's. So it'd be 3 times 12 plus 2 times 18. And that would give us a total amount of 72. And it was meters, 72 meters. And so that answers both parts of that question. Moving on to example 3. This is asking for the largest possible area for a right triangle whose hypotenuse is 5 centimeters long, and then what are its dimensions. So again, we're trying to maximize the area. Let's start by first drawing a picture. So it's a right triangle, the hypotenuse is 5. And again, maybe we'll just call this x and then y, the 2 dimensions of the triangle. And we're going to be figuring out what those dimensions are. Well, I know that the area of the triangle is going to be 1/2 times the base times the height. 1/2 x times y. But again, I'm supposed to find the derivative of that, and I can only find the derivative if I have one variable, but here I have 2. So somehow I have to get x in terms of y or y in terms of x. And it's probably better or easier to get y in terms of x just because we're more used to that. So I have to figure out, using this picture and the given information I have, a way to relate x and y together using a different formula. I can't use this one because I need to use this one for my area. So I have to use something else to get y in terms of x. So hopefully you thought about the Pythagorean theorem. So we could remember that this side squared plus y squared would equal the hypotenuse squared. So I know that x squared plus y squared is equal to 25. So that tells me that y squared would be 25 minus x squared. And then of course that y is equal to, and then of course I'll just use the positive square root because I'm talking about a length. Y is not going to be negative, so I would use the positive square root of 25 minus x squared. So now I can substitute this into my formula for area. And then I can have a formula for area in terms of just x. So I would have 1/2 x times the square root of 25 minus x squared. Now, my goal is to find the maximum area. So I'm going to go ahead and find the derivative of this, which is going to require a product rule, where 1/2 x could be my u, and then the square root function could be my v. So u is 1/2 x, v is the square root of 25 minus x squared. U prime is 1/2, v prime is 1/2 times 25 minus x squared to the negative 1/2 times, chain rule here, negative 2x, because I had to multiply by the inside, the derivative of the inside blob. So then I'm going to do u prime v plus v prime u. And that'll be my derivative. So u prime v would be 1/2 times the square root of 25 minus x squared. V prime u would be 1/2 x times all of this. Now a couple things to notice is the 2's will cancel here. And then I'm going to multiply these x's together. So I'm going to end up with, and since this is negative, it's actually going to be minus. So it ends up being minus x squared all over 2 times the square root of 25 minus x squared. This goes in the denominator because the exponent was negative. And then I need to set that equal to 0. Now, it's going to be much easier to set this expression equal to 0 if I can combine it as one fraction. So what I want to do here is create a common denominator. So I'm going to multiply the top and the bottom of this fraction by the square root of 25 minus x squared. I don't need to worry about this 2 because this already has a 2 in the denominator. When you multiply these two square roots together, they cancel out. So then you end up with 25 minus x squared minus x squared all over 2 times the square root of 25 minus x squared. And that becomes 25 minus 2x squared all over 2 times the square root of 25 minus x squared. Now, setting that equal to 0 is really easy. All I have to do is set this numerator equal to 0 and then solve for x. So when I do that, I end up with 2x squared equals 25, x squared equals 25 over 2, and so x is equal to the positive 5 over the square root of 2, and you can just leave the square root in the denominator, it's okay. And again, I'm only taking the positive square root because I'm talking about a length, so I wouldn't want to be working with a negative value. Also, you would want to find where the derivative is undefined, which is what x is 5, but that wouldn't make sense with the context. I can't let the base of a right triangle be the same as the hypotenuse. So x cannot equal 5, neither can y. So I don't need to worry about where the values are undefined. I'm just going to look at this value right here, 5 over rad 2. That's my one critical point. That's going to be my maximum for this area. So the area I get when I plug in 5 over rad 2, I would plug it into this formula here. And we'll go ahead and answer the question. So the question is, what is the largest possible area? So the largest possible area is what I get when I plug 5 over rad 2 into this equation. And so then I end up with 1/2 times 5 over rad 2 times, again, 5 over rad 2. And so I end up with 25 over 4. And that is centimeters squared. So that's the largest area. Then the dimensions, well, I have one of them here is 5 rad 2. And then to find the y value, I would plug 5 rad 2 in here. So the dimensions would be 5 over rad 2 for the x, and then if I plugged 5 over rad 2 in for x squared, here, I'll do it right here. I'd have 25 minus 5 over rad 2 squared, which is 25 minus 25 over 2, which I had right here. And then 25 minus half of 25 is equal to half of 25. So that equals the square root of 25 over 2, and then that would just be 5 over rad 2. So basically, the triangle that gave the maximum area was an isosceles right triangle. The dimensions were equal. And so there's our official answer to this question. So this section is going to revisit the idea of velocity and acceleration, as well as profit and cost. So example 4 is just kind of a review of what we have done before, but now we know the best way to find the maximum height. We didn't learn this before. So it's giving us the height of an object moving vertically, is this equation. So right there is our position function. It says that it tells us to find the object's velocity when t is 0. So we have to remember that velocity is the derivative of position. So it would be equal to s prime t. And so that derivative would be negative 32t plus 96. And it just says to find that when t is 0. So that's just kind of like a review of how this works. So that would be equal to 96 feet per second. Then it's asking you to find the maximum height. This is the new thing. This is the thing that comes specially with chapter 4. We know that the maximum height will occur when velocity, which is the derivative of position, equals 0. That's when you will have your maximum height, because that's when the object changed direction. That's what makes the velocity 0. So then we set this equation up here equal to 0 and solve for t. And so we find that the object will reach its maximum height when t is equal to 3. So, but this wanted us to find what the maximum height was. So we know when it occurs. It occurs when time is 3. And then the maximum height itself would be equal to s of 3. So I would plug that in here. And when I do that, I get 256. And that would be feet. 256 feet. Last question it wants to know is, what is the velocity when s, that's the position, is 0? So I'd have to take this position function up here and set that whole thing equal to 0. And so this is just like solving a quadratic. Maybe I'll factor out a 16, a negative 16. That will leave me with a negative 6t and then negative 7. Now if I factor that, I get t minus 7 and then t plus 1. And that would give me a time of 7 seconds and then negative 1 seconds, but let's just stick with positive time, so I'm going to throw that solution out. So it looks like the position will be 0. It's going to hit the ground. The object will hit the ground at 7 seconds. So s equals 0 at 7 seconds. But it wants me to find the velocity. So I need to find v of 7. Or that's the same thing as s prime of 7. So I would plug 7 into the derivative. So that would be negative 32 times 7 plus 96, and so I get negative 128. So the object hit the ground at a velocity of 128 feet per second. And the negative just means the object was falling, which makes sense. All right, so that's just a review of position and velocity.